We need to build robust systems. If something fails in a part of the system, we need to have systems that are robust enough so that other parts of the system can take over.
Can you imagine feeling completely safe, knowing that if all else fails, the car you're driving, the train that takes you to work, the airplane above your head will not crash, even if critical parts in these systems fail?
If something happens with the computers that are on board of these systems, then of course it can be actually life-threatening. So in the Admorph project, what we try to do there is, if something happens to these computer systems, we try to reconfigure these systems by adding all kinds of smart technology there in such a way that these systems can continue operating and maybe save lives in that case.
Complete certainty gives peace of mind. However, how certain can we be if a split second can mean the difference between safety and disaster?
So time is the most critical feature in all these systems. So within Admorph, I am the timekeeper. So I basically specify for the given system how much time do we have to react to an unexpected event.
In a world where our infrastructure, well-being, and safety are constantly threatened by malfunctioning software, hardware, or even attacks from hackers, the Admorph Project researches ways to prevent the worst from happening, even when critical parts of these systems fail.
You can see it as a new mode of safety, indeed. Many of these systems are that complex that they have multiple processing elements in them. If one of these processing elements actually stops working, something happens to it, then, for example, we are looking into mechanisms that steer the system in such a way that other parts in the system can take over the functionality that was on the failing component, in such a way that the entire system still remains operational.
Within the Admorph project, academic and industrial researchers collaborate. This way, the theoretical principles can be tested and applied in the real world.
The avionics is one of the highest standards in terms of certification, and this is why it's a huge challenge for us.
In this domain, mission and safety critical systems need to be thoroughly tested before they can be used in an actual flying airplane.
And we need to provide guarantees that the system will respond within this amount of milliseconds in order to be able to certify that this is actually safe for the public.
The computers used by most airplanes today rely on robust and proven technology that was developed decades ago. However, the exponential increase in processing power of modern computer chips has an enormous potential for innovation. Think of airplanes that can do autonomous tasks and communicate in advanced data networks. Imagine autonomous flying systems and other transportation systems, like trains and cars, that are able to solve problems without human intervention. The challenge is to safely apply this modern technology. It's our vision to build a future where adaptive systems can reconfigure when needed. Throughout Europe, our researchers and industry partners fundamentally investigate mission-critical and safety-critical systems.
It is very important to gain the knowledge that we are acquiring in this project and apply this knowledge as locally as possible.
This knowledge can be applied from aerospace to healthcare, from water supply to supply chain, from our energy networks to the financial industry.
So it is also economically very important for us in Europe to do this kind of research that could enable us create new markets, maybe even within Europe. It is much better not to rely on technology that is coming from far away, but instead of that, creating that technology yourself.
Admorph researches the possibilities in building robust mission and safety critical systems. Systems we all use and depend on, now and in the future.